Hello everyone. So today our video is going to showcase the principle behind the working of a helical spring and to determine its spring constant from the graph plotted between its loading and extension. So what exactly is a helical spring? A helical spring is a mechanical device which is used to store energy and subsequently release it to absorb shock or to maintain a force between contacting surfaces. Here, the energy stored and released by the spring is understood by the application of Hooke's law. Now, what is Hooke's law? The law states that within the limit of elasticity, stress applied is directly proportional to the strain produced. So, the mathematical representation of Hooke's law becomes F equals to K into X, where F is the weight of the load, K is the spring constant, and X is the extension produced by the spring. Before we start off with our experiment, let me introduce you to the equipments required to perform it. First, a spring, a rigid support, slotted weights, a vertical wooden scale, a fine pointer, and a hook. Now, to give you a better knowledge of how this whole experiment works, let us perform it. First, we suspend the spring from a rigid support and attach a pointer and a hook from its free end. Then we hang a 50-gram hanger from the hook. We take a vertical wooden scale and set it in a way such that the tip of the pointer comes over the scale. Then we note the reading of the position of the tip of the pointer of the scale against the zero load, which means the mass of the hanger is considered. But the problem that arises here is that the extension produced is very small, so small that at the time of unloading you won't be able to calculate the extension value because it will be so negligible. Thus, we go for a higher mass of around 250 gram. Extension produced by this load as the reference point, we calculate the extensions produced by all other masses, that is, for 300 gram, then 350 gram, followed by 400 gram, and each time we add slotted weights of 500 gram. Similarly, we also take down readings of unloading, that is, for the length moved by the spring every time we unload a mass of 50 gram from the reference mass of 250 gram. Hence, the masses are 200 gram, followed by 150 gram, and finally leading to 100 gram.
On performing the experiment for the earlier mentioned masses for both loading and unloading, the readings of extension were noted down as follows. Lastly, we plot a graph in two quadrants, one for loading versus extension and the other for unloading versus extension. The graph obtained is a straight line in two quadrants passing through zero. This graph is used to calculate the value of the spring constant K by dividing any one value of loading or unloading with its corresponding value of extension X. Helical springs and the principle behind it is used in several places, such as for applying forces and controlling motions of vehicles while using brakes and clutches, to measure forces in spring balance as used in lab experiments, also to store energy in watches and toys, and lastly to reduce the effects of shocks and vibrations in vehicles and machine foundations. Hence, we conclude that the force produced because of loading and unloading is linear to its extension produced, and then the slope of the graph gives us the value of spring constant and is same for any value of extension and force as long as the spring remains the same. For the spring used in our experiment, the spring constant was calculated to be 16.6 Newton per meter. With this, we come to an end of our experiment.